Alright guys, so hi everyone, hope you're doing great. Today we will be talking about databases, controlling of information, how we can store information and how we can control information. Okay, so that's the topic. In the previous couple of lectures we talked about operating system, we talked about general architecture of computer, we talked about networking, and we also talked about some other basic stuff. Now today our lecture would be about databases because it's also a very important uh, topic in tech especially. So here we would be learning about databases, why is the need to store some information, and what are different ways in which we can store information, and sort of things like that. So every week we have the capacity to double our current store of information. So that's now in this chapter we'll learn about why has the last third of the 20th century has been dubbed the information age, why it's called information age, and what computers, readable media are used to collect data, and how our statistical method used to transform data into information, and what are the elements of databases, how our database management used to organize data, what are some advantages and disadvantages of database. I don't think there is any disadvantages of database, but let's see what are some advantages of web-based databases. So what are these? We will learn about all these things one by one. All right. So why is it that the last third of 20th century is called as the information age? Because we are, if you look at the age which we are living in, it's why it's called the information age, because you can see that we are constantly bombarded with information, facts, figures, opinions, stories, picture, videos, uh, you name it. There are lots of things, information we gather every day, terabytes of data every day. Internet users alone generate terabyte of information daily. Now think about that. Uh, every terabyte is around 300 pages book per month. So we 70 million 300 pages book per month. Just look at the scale at which information is being generated, and we no longer store information on bulk of papers because we have computer technology which provide us different type of data storages. Like there are lots of databases, cloud storages, which or you store all these things. So that's why it is called as information age. Now here we will examine the role of computer playing or performing. Uh, Computer is being used to collect and manipulate large amount of data. Now in an era of artificial intelligence and data science, you can get the idea that how much huge information is being collected and manipulated each day. Your LLM and all these things, how much information they manipulate each day. Just to think about it. Accessing that data in a timely fashion. Let's say you ask something from ChatGPT or DeepSeek or something. How does it get all the data, and how does that work? How does it give you the answer by manipulating different sort of data? So that's the scale at which we are manipulating data through computers. How does it analyze or format it for easy understanding? How does it work? Now, data and information are generated uh, or generally used together and interchangeably. However, they have specific use, and data, as you can see, data is something which is a name given to things of fact. Again, information is data repackaged into meaningful form, uh, which we could understand and use. That's called as information. That's the basic difference between data and information, basically. So, in order to include whatever data might be needed, database must be carefully designed. So, in order to store some information, let's say you are creating a database for a school, then you need to store your data carefully. You would have name of the students, roll number of the students, for the name, phone number, and all that. So you need to uh, carefully design the database for storing information. So database programmers and users of the database must answer the following questions whenever creating or designing some database. How can we effectively collect large amount of relevant data? How we can reliably store that data for later use? And who will use the data? How often will they need to access the data? What format will they need the data in, text, numerical, visual, or whatever? How will they use the data, and so on? So programmers or users who want to design a data that these questions must be answered before designing something for a database. In early computers, there are lots of ways in which computer used to be stored, data used to be stored or collected. For example, here we have Hollywood card, which are used for extending storage of data, and where each card consists of 80 columns of digits from 0 to 9, and each column is presented to one character. Okay, and data was entered using a key punch machine and read with a card reader. So in the early days of computer, this was the way in which computer used to store data, and that's how it used to work. So here is a paper collected in a form that computer could read directly. Now here's a for paper which paper could directly read, computer could read directly. Mock sensor data collection sheet, a sheet of paper used to collect responses to multiple choice question using graphite pencil, and responder fill in a small space indicating answer on the computer. So it used to be like in our tests, all that. We also used to use that because it automatically scan the answers chosen by the people who get the test, and it automatically collect the data of the answer sheet. So here's also a slide imagery data collection, where remote electronic data sensing is used to sense device, remotely sense the where remote sensing devices were used to collect data from the space, and these slides collect million of times of more data than an entire 10 years census. Okay, so that's the amount, the scale at which information is being collected from satellites. Or if we talk about Hubble telescope, which is one of the most advanced telescope up in the space, collects 85 million bytes per second. Okay, and then we have we have the satellite image of Washington DC. So that's the amount, the scale at which information is collected for it. This is the you could see the image which the slide has captured. Now barcode are also used in shopping malls, or you could have seen, or in general uh, you would see everywhere the barcode which are used to collect data, and it uses a combination of thick and thin lines to identify specific item in an inventory. So that's what it is used for. Then we have data probe tools, which are key-like instruments, which when inserted into meter will electronic read and record meter location and usage numbers into computer. That's also used tools which are used for data collection. Camera could be also used for data collections, and microphones, yeah, voice recognition data entry. That's also data entry, like a tool for data collection. It collects information when it speaks into the microphone of a portable terminal. The receiver computer accepts the voice transcription and transcribe into a form of the computer can store. So that's how data is being collected. Or uh, we could also collect data through interactive data entry online. For example, in some website you could like there are lots of website or forms, Google Forms you could say, through which we could collect data interactively. And then the second thing is retrieving data from the database. Once the data is being stored in the database, the second important thing is how we can retrieve the data effectively. Okay, effective data retrieval is affected by how well the files were organized. The more organized the files are, easier it becomes uh, to fetch or to retrieve data. For example, FBI fingerprint processing. It is STD is data collection, storage, and retrieval. So FBI used to maintain a database of over 270 million sets of fingerprint, which collects all the fingerprint, and there is a separate way through which it's being collected. You could also take an example of NASA, which takes data through takes all the data about different people and issue a smart card for that. So that's again an example of effective data retrieval and organization. So here's a detailed example of how FPI's storage work. I don't think we need to emphasize more on that. You can just go through the slide to be yourself. Visualizations of information, we can also represent our information visually. For example, here is we have population densities in 1970s. I don't know if we have 1979. It's just an example to give you how does information could be visualized. Then we have ultrasound imaging. It's widely used in medical diagnostic techniques that provide a visual image construction from the sound that reflects off various organ parts of the body, and it's also being used for retrieving data. Now, what's the role of statistics? And one thing which I would like to mention here, that you'd also learn statistics and probability as a whole, like as a separate course in your coursework. But here I'm just giving an introduction or overview of the role of statistics in transforming data or data into information or data information. So here we have the retrieval process involves the examination or summarization manipulation of data, and statistics help us with that. Okay, it helps us with examination, summarization, and manipulation of data into information. Now, most commonly used method of transforming data is statistical analysis. Some important statistical concepts include percent, probability, selecting data from statistical analysis as sampling, normal distribution, correlation. These are some of the important concepts in statistics. First off, we have percent, which typically describes a special type of fraction. It's the number of parts out of total of 100 parts that are in the question. For example, 25% of 100 people would be 25%, or 20% of 10 dogs would be 2%, and things like that. So it's just out of, you could just simply define it as out of 100. We call that percent. Then we have probability. It just deals with our ability to predict whether certain events will occur or not. For example, it just tells you the chance of something occurring or not. So it just tells you about that. For example, 50% chance of showers this evening, This prediction is based on probability and that certain patterns of observed weather will continue. So probability deals with that. It just tells you the chance of happening of some event. And then we have gathering data on particular data, how we could gather data on particular data. There says different ways. For example, we just first we do sampling. What is sampling? A sample is just a small group used to represent much larger group. Okay. For example, you are collecting data of students. If you take a simple students of a small group, then that would be a sample. Okay. And sampling is just a technique of predicting a total situation using a comparative view isolated representatives. Like if you uh, take a small group and predict the situation for the whole using those small groups, then we call that sampling. Okay, sample must be carefully selected to avoid predetermined statistical result, and sometimes skewed sample would cause an error. So skew error sample is basically it's a selection of group participating in survey sports, some predetermined outcomes. So you could say that it's an error or a mistake in sampling. If a sample is randomly chosen, we can expect some semblance of normal distribution. So what's normal distribution? Normal distribution is just 68% of all data will is false or then a limited range near the center of the distribution. I think we don't have a graph for that. It just give you a curve type shape. Okay, it's a curve type shape in which 68% of all the data falls within that limited range. Okay, that's called as normal distribution. You'll do learn about this in detail in your statistics and probability class. It's a very important concept. Then how we can perform statistical analysis on data. There's we can do correlation. Correlation just states a connection or linking of two or more pieces of information with each other. And there is a correlation between index finger length and whether a person is male or female. For example, based on the index finger length, we could say that the person is male or female. For example, the average centimeter of males is 74 to 72 centimeter, while in case of females, 68 centimeters. So if the data lies close to 68 centimeter, that could be female, and if that is as a two, that could be male. So it's just correlation between those two things. There is also an error or false correlation thing here, which we need to understand about, or it's also called as false relevance, in which you just falsely correlate something with the other. Okay, so it involves the creation of cause and effect relationship between two facts that seems to be correlated but are not. The fact must be true, but the relationship is not. For example, all human beings breathe oxygen. Okay, all human beings breathe oxygen. All human beings must die sometime. These are two facts, but the false correlation or false relevance will be oxygen must be toxic because 100% of those breathing oxygen today will die in the future. So that's a false relevance. I think you got the idea that what's mean by false correlation or false relevance. All right, how can we create a database, custom database? So creating a custom database for something is, software engineers do all the time. So in order to create a custom database, you need to create, different fields, different for that, and you need to specify the relationship between those. So first off, what is database actually? It is just an organized collection of information. Okay, and the arrangement of the typical database would be in the form of field, which I just mentioned. It's a location which contain one specific piece of information. For example, it could be name, it could be gender, it could be age or something. And then we could also create a database based on records. Records is just a collection of related data items. For example, you have a record of one person. You could store that as a record, okay? So, for example, name of person, age of person, gender of a person, and so on. If you store that in that way, that could be also database, but in a record, that would call this record, okay? And then we have file system. It's a group of records that all at the same time. Then we call that, for example, last, first, ID, phone number, DOB of a person. Could be a file of different people. For example, if you take like you know, this is a record, and if you store too many records, it become a file. Okay, as let me give you an example. In there are many fields in records, and there are many records in files. So just keep that in mind. Then we have for database management system. It's a software application that allows you to store, organize, and receive data from one or more databases. So it's database management system. It's used to manage the data inside the database. For example, MS Access could be a database management system. Java Oracle is a database management system. So these are some of the database management systems which helps uh, to store, organize, and retrieve data from one or more databases. Okay, and these combines into a complete package where they have a structural element of database, field record files, a query language, program of data manipulation, and programs for statistical analysis and report writing and all that. Now, using a relational database system, so there are basically two types of database systems. One is relational and one is non-relational. In relational database systems, it's most commonly used where one field or item is related to another. Okay, that's how database is being created. It's a two-dimensional table called relation to store data, where relations are linked to each other by common field. And the relational model has two important features, like its structure is simple and direct. Its structure is well suited to the client-server environment. Again, I think we had discussed client-server architecture in the previous lecture, and it involves two computers to connect by a network, and database resides on one server, and the server needs to access the database on the other client. So this is just it's telling about how does the client server architecture works. All right, so steps to create a new database using DBMS. First of all, when you are creating a database in your database management system, you need to decide what information you might need about the subject. And let's say you want to store information about you want to create information of different employees, your employees. Okay, so for that you would take the ID of employee, name of the employee. You could also salary of the employee, role of the employee, and all that. So you need to understand what information you might need about the subject, and also you need to define the structure of the database. That what would be the structure of all that, and then you need to enter information about each item. You need to select exactly the information you wish to extract and update the database, and you could also print out all the parts of the database in format of your choice. Now, using information to enhance targeted marketing in business world. So in business world nowadays, database data is considered as the new oil. You know, so in data warehouses, data is being stored, or those data forms. We call that the data forms. So in data forming, data is being consciously formed or collected, and based on that that's being used for different advertisement and all that. For example, when we search something on YouTube or on Google or somewhere, they show us the ad related to that. Let's say if you search something on Google, then maybe 10 minutes 20 minutes later you an ad pop up on your screen related. That's the thing which you just searched about. So that at that level that is being collected. Now, data warehouses or data modes, so it's just warehouses or data farms or other places where data is being collected, stored, and then used for to better provide customer service or to do better market analysis and or to do a targeted marketing. And data mining is just searching collection of data to discover relationship and global patterns that exist among them and rely upon these patterns to assist in management system. It's just yeah, that's data mining is just mining data or collecting the data, searching for the collections of databases. Now we have also the advantages of data. It saves our space, it increases accuracy, it uses multiple data. Data integrity means our data is being securely stored somewhere, and it's easier to secure them. It saves a lot of time for searching all that. It's easier to use the data because you could just retrieve the data from there with just a query command. And there are also some ethical hazards of database systems. Data could be misinterpreted. That's you can trust the source of the statistical analysis. So there could be misrepresentation of data. So there is always a chance of data being misrepresented. So invasion of privacy. Let's say if you have a large database and someone invades your privacy, or you are, let's say you are watching something on YouTube or somewhere, and your database is being stored, your personal data, personal information. So that's a kind of privacy invasion as well. Large databases hold personal information about each of us. You know that. Universal identifier, the collection of all citizens' data obtained from single source. And lastly, we have web database connectivity. If any one of you know about web development or application development, you must understand that we need a database to dynamically show content or dynamically show data on websites or applications. Okay, so we so for that we need a database connectivity, which is the interaction between one or more web pages and the content of a specific database. So the web pages are designed as templates. They are just templates which to which data is being rendered from the database. Okay, and image areas and text boxes to be filled with data from database. Separate the design and layout from the web pages from the content to be displayed on the screen. And query-based programming, which we discussed, I think, in the previous lecture, which are four generation query languages which select web content from the database and display dynamically generated web pages. So we use query languages to render our content or fetch data from the database and render into the front end of our web pages. Then key advantages of web database connectivity. Um, there are some advantages or perks of web database connectivity. Database information is universally being available, because when you make your database available to your consumers through web applications, it's being accessed worldwide. So that's a kind of you make some data universally available. And website design and development are easy and faster. So that's also an advantage. And website maintenance is easier and more efficient because the database part is being separated from the web pages, and adjustment can be made by any unauthorized person rather than web developers. So that's again one advantage of the web database connectivity. And websites can display updated calculation and informations uh, which are being updated to the database. So that's again. And then we have getting started, connecting database to web. So in order to connect your database to your web application, you need a middleware, software in the middle, which could talk with the database and also talk with your web application or web server. So that's where we need middleware, which act as an intermediary between web server and database. For example, Java could be an example, SQLite could be an example, and middleware access more database using ODBC. Keep that in mind that middlewares, how does the middleware, the software, the middle accesses most data by using ODBC. What's ODBC? It is Open Database Connectivity, which is just a set of standards or protocols allowing information to be passed from database to dynamic web pages. And we also use query languages, the language that database can understand. Query language is the language which database can understand. And for example, we have SQL, SQL structured query language, or we have many other things. NoSQL is also being used in non-relational databases. We have also query wizard, like so the wizard. This will help frame the request for retrieving specific data from the database, and it get appropriate data from the database and as an appropriate data program. Lastly, we will just Oracle WebDB. It is an integrated solution provided by Oracle, which is which also the I think the owner of Java, maybe, yeah, Java. So we have a complete it gives a complete integrated server solution, high-end database program for building, loading and monitoring web database application, and content-driven websites. It can help create and manage database object, develop HTML component, build and maintain content-driven website. I think Google Firebase do the same thing as well. You could also take an example of that. Google Firebase, check that out. If you don't have an idea about Google Firebase, that's also an example of web database connectivity. So I think yeah, that was just an introduction overview of this lecture on databases. I hope you got the idea about what is a database and why a database is being used. For now, I would just say that database is just used to store data, and we use different tools to store data and different methods to collect, retrieve, and manipulate data. So that's all for this lecture. See you in the next one. Till then, keep learning and keep improving yourself.